This video is on the definitions of acids and bases and what it means to be a conjugate acid and a conjugate base. Okay, so to do just a brief review, we have talked about acids before, but we're going to put a name with this now, and that is that there are a couple different definitions for what an acid is and what a base is. And so the first one is called the Arrhenius definition, and this was a scientist who linked acid behavior with the presence of H plus ions and base behavior with hydroxide ions, or OH. And so basically Arrhenius said that an acid is one that increases the H plus concentration when dissolved in water. So an example would be like HCl, because when HCl is dissolved in water, of course, ionization occurs and H plus is created. And then our Arrhenius base was one that increased the concentration of the hydroxide ion when dissolved in water. And so something like sodium hydroxide, who's a pretty famous Arrhenius base, because upon ionization, hydroxide is produced. So to be an Arrhenius acid or base, basically to be an Arrhenius acid, you have to have an H plus, and to be an Arrhenius base, you have to have an OH minus. And so that is one definition of acids and bases. The problem was that that definition has some limitations. So the Arrhenius definition has some limitations, and it doesn't quite encompass all of the acids and bases that there are. And so there's kind of a more general definition, which is going to involve the transfer of an H plus ion. And so that is going to be the Bronsted-Lowry definition. But before we can talk about that in particular, I want to talk a little bit about H plus and water. So the first thing to talk about is, when we're talking about H plus, it's important for you to know, if you think about, before H plus, I guess, if you think about the hydrogen atom, it's one proton and one electron, 0 neutrons. So when hydrogen becomes an ion and loses the electron and it becomes H plus, it's really just a proton. So you will hear some, professors, some teachers call H plus a proton, because it, in fact, really is only a proton. So that's something interesting to think about. And then the other interesting thing is that when H plus reacts with water, it forms H3O plus, which is the hydronium ion. Looks like this in terms of a Lewis structure. And so it's important also to know that chemists use H plus and H3O plus kind of interchangeably, because basically, chemically speaking, they behave the same way. And so it's important to know that an H plus and H3O plus are kind of a chemist's version of synonym, so to speak. Okay, now we can get a little more into Bronsted-Lowry. So Bronsted-Lowry, and I'm going to say BL for Bronsted-Lowry, acid is one that is defined as a substance that donates an H plus or a proton to another substance. And a Bronsted-Lowry base is a substance that accepts an H plus or a proton from another. So Bronsted-Lowry acids and bases often, well, I shouldn't say often, they involve what we refer to as a proton transfer or an H plus transfer. Okay, and so really we can kind of break this down to say a Bronsted-Lowry acid is a proton or an H plus donor, and a Bronsted-Lowry base is a proton or an H plus acceptor. So that's the very general definition of Bronsted-Lowry acids and bases. I want to show you this in two examples. So the first one is HCl plus water. And let's see, we get, these would be the products. Okay, so if we think about what's happening here, my HCl gave its hydrogen to water, right, to then end up with H3O plus and Cl minus. And so this would be a Bronsted-Lowry acid because it was a donor of a proton, and water in this case is playing the role of a base because it was a proton or H plus acceptor. All right, so the HCl transferred an H plus to water. So this is interesting because it's kind of the first time we've referred to H2O being a base because it can accept a proton. But what's also interesting is it can also act as an acid. So if I have this situation, NH3 or ammonia reacting with water, these would be the products. Okay. We're going to learn very quickly that NH3 is a very famous base, and I want to show you in this case why it's behaving as a base, which means that water is behaving as an acid. So NH3 is behaving as a base because it accepted an H plus from the water, and so water is behaving like an acid because it gave an H plus to the ammonia. So it always takes an acid and a base together to transfer a proton. So that's something important. Let's see, acids and bases always work together to transfer a proton or an H plus. Right? And then the second point that I want to make is we just saw this with water, and that is kind of a vocab word, which is the word amphiprotic, and that is a substance that can act as both an acid and a base in certain scenarios. So we just saw that with water. Water is a very famous amphiprotic substance because we just saw up here in this first example where water acted as a base, but then in the next example we saw water acting as an acid. And so that amphiprotic is the word that is used when you have a substance who can behave as both. There are more examples than just water, but that's probably the most famous example of an amphiprotic substance. So I believe I'm going to stop there. I said I was going to talk about conjugate acids and bases, but I will save that for a second video. So that is the two main definitions of acids and bases. Arrhenius said that acids have an H plus and bases have an OH minus, but we just saw that Bronsted-Lowry can expand that definition to talk about a proton donor being an acid and a proton acceptor being a base. And that's what makes ammonia a Bronsted-Lowry base, because it can accept a proton, but it's not an Arrhenius base because it doesn't contain the OH minus. And so that's kind of an interesting definition, except that when it reacts with water, it does create more OH ions to add to the solution, which I guess technically is the definition of an Arrhenius base, but it surely doesn't look like the bases we think of when we think of, NaOH, same thing with a hydroxide. So those are your two main acid-base definitions.